So good afternoon, good day, good morning to everyone. I'm Rostislav, and today we will have the second part of our Friday talk. And today we will talk on the 8-inch industrial RO units. We have started talking on the units last Friday, and today we will continue. I would like to introduce my colleagues. So today we will have two colleagues from us, from Ecosoft. So the first I would introduce Alexei, a gentleman. You can see Alexei on the screen. So Alexei is a sales manager responsible for sales of Ecosoft products in the Western European countries. And Alexei is known to be the best salesperson for both industrial and commercial 4-inch RO. So Alexei is doing quite a good job, and he came today to us to ask questions and to help you and help me to better explain our products. And also, I would like to introduce Alla. So Alla is a salesperson for the north of Europe, mainly for the Scandinavian countries. And I believe many of you already know Alla because Alla helps you every time when you place order. And Alla is doing her best to deliver everything you need. So today we will have questions both from Alla and Alexei. So Oksana is traveling today, so she's has not joined us. What we do for those ones who maybe joined us for the first time. So first, we do the Friday talks on Fridays, not every Friday, but we do our best to do it regularly, at least 2-3 times a month. And we select one particular topic and discuss mainly one product during the 45 up to 60 minutes. So today we will talk on the industrial 8-inch RO, and this is the web page of Ecosoft. And you may find on the web page a special landing on the Friday talks where you could register. So you can join us by pressing this button. And also what is more important, that you can see all the previous live talks you could see online here. This is for your convenience. Also, you may go to YouTube and visit our channel. So if you would subscribe here, you would see even much more videos, not only from Friday talks, but also videos that appear about Ecosoft products that came aside from the Friday talks streams. And if you would subscribe and a new video would be downloaded, you would get a message in your account that another useful video has appeared. So I would suggest you. I would also take this opportunity to do some advertisement of the new videos. So I'm pointing out the hygiene guard. This is the chlorination cell that we have recently added to our product portfolio. This is the chlorination cell that can be used with the clock valves. Yeah. And today we will talk on the industrial RO units. So I will use again the web page a little bit to explain the product, which is actually behind me. And basically, we would spend much more time looking at the product, not on the web page. So this is the product portfolio that we have. So we have the industrial 8-inch RO, and we produce them in 2 lines. In 2 lines, the Inox series and the regular series. So Inox series, we have the products with 2 membranes. So this is the smallest one, and we end up with a 9-membrane element unit. And in the regular version, we have 2 up to 48 elements in a system. So this is what we produce. All the units that have the capacity 2 elements up to 9 elements normally are available on stock in Belgium, and we can deliver them tomorrow when you need them urgently. So this is very handy for you. And also we have the portfolio of membrane elements that we would also talk today, and a variety of of the various of the options. So today, in front of me, we have the unit with 3 membrane elements. So this is Inox version, and we would talk in details on this particular product. So I will stop now the presentation, and we can actually jump to questions from Alexei and Ala.
Yeah.
And let's ask
Hello,
our
everyone.
guests
Hello, Rusty.
if the sound is okay. If you can hear us well, if the picture is good, just give us some signs that you are with us and you have joined us.
All good.
Yeah, Yulia can hear us.
Yeah, thank you.
That's good. So now we can start with questions.
Yeah, hello everyone. Yeah, of course, I have some questions for you, Rusty. And by the way, thank you for such a great presentation of me. And as I remember, last Friday we stopped on the options such as
Alexei,
permeate flushing.
Can you please wait, because I cannot hear you.
Only you?
Yeah, I can hear you. I think Rusty has
Just a moment. Can you?
And now? Now it's better?
Now I can hear you.
Oh, super. So, last Friday we stopped on the options such as permeate flushing kit, blending kit. So could you please continue from this part and give us a bit more information about why the customers need it?
Yeah, why do we need that?
Yeah.
Yeah, the blending kit. I will start explaining the blending kit by showing it. So here is the. I will bring it closer. So a blending kit is a separate product with it comes in a box, and it has a label, and the blending kit. Yeah, maybe I will repeat something from the previous Friday, but this is okay. Oops. Okay. There's something. So this is the blending kit actually that we can use for 2 reasons. So the first reason is to adjust the quality of the permeate. For example, you do the water filtration for the brewery production to brew beer, and you need the TDS of around 150 ppm. So when you put RO unit in place, basically, if the water is below 1,000 ppm, if the feed water is below 1,000 ppm, you would get like maybe 20 ppm of the TDS of the permeate. And then to adjust the quality of the permeate, you install this blending kit. Actually, you could adjust the amount of water that is blended, and finally, you would have the necessary amount of salts, necessary TDS in the system. So I will explain it. I will show it on the system. So basically, the skid or the frame of the unit is already prepared for the installation. So if we can show it from that part. So here we have already a thread on the top, a thread on the here in the middle, and then inside the box you have the clamps. You have all the necessary parts to connect, and basically I would just show it how it would look like. So this is the way how you connect the blending kit, and here on front you have the regulation. So it is quite well thought for your convenience to make it easier for you. So I put it back. What is also important that in the box you have a manual that explains what is inside, how it should be fixed step by step, the hydraulic connection, and also what is more important and a little bit more complicated is the wiring. So we explain how the wire should go in the power panel, and also here we have a picture and the names of the contacts where the wire should be connected. And finally, on the last two steps, we have the recommendation on how the controller should be reprogrammed. And here we marked it in red, how the controller should be programmed to make this blending kit working. So you have it also in the box.
Good.
So this is a short answer to the question, what is the blending kit and why you need it.
Okay, thank you, Rusty. May I ask you, and could you please show us like the most important parts of the water flow of the system, how it works, and the main parts of it?
Yes, so I will again jump to the system, and so first I would like to remind to everyone that this particular version, Inox version, is on the wheels, and you can easily move it when you do the maintenance and when you do the membrane placement. So basically the water, this is the feed water inlet. On the feed water inlet, we have the motorized ball valve. Then we have a very convenient module where we have a lot of small tools, small but important tools. So first you have a TDS meter. So this is actually not a regular version of Inox. This is a version with the eConnect controller, and this is why we have the TDS on the inlet. The basic version, the basic Inox version does not have a TDS measuring. Then we have a sampling tab where you could just take the water to measure the TDS, maybe pH. And then we have two injection points. So this one is regularly used for the anti-scalant injection, and the second one can be used for pH correction or biocide dosing. So they're already in place. You have the plugs here with the, I think this is 1/2-inch thread, where the injection nozzle of the dosing station can be easily connected. Then the water is supplied to the sediment module. So it consists of 3 BB20 housings that are installed in parallel. Important to mention that the cartridges are also supplied with the system, so they are in the box. Then the water from the units are supplied to the high pressure tank. And also I would like to draw your attention on the other plug. Maybe we will come back to it. This is the permeate flushing inlet. This is another option that can be connected. Then we have a high pressure pump. And after high pressure pump, we will go around. We will go around, and then I would like to show that after the high pressure pump, we have the Inox high pressure line. So this is stainless steel 316, and the water from the high pressure pump is delivered to the first membrane pressure vessel. And as you have noticed, all the membranes are connected in series, so the water flow goes one to one from another. It is very important to also draw your attention on the arrows on the pressure vessels that explains the water flow. But besides the water flow, the arrows shows the direction how the membrane elements should be loaded in the pressure vessels. We will also show it to you today. So then after the membrane elements, then we have the permeate. Then we have the permeate line. So this is the permeate line is in the middle of the membrane pressure vessels. It is collected, and then we have the flow meter on the on the permeate line. And here in this particular version, here we have the electronic water meter that shows the liters per minute flow. Also here on the permeate line, we have the TDS meter that explains that actually measures the conductivity, or TDS in microsiemens or part ppm. It depends on what you would select in the manual. Also, we have here we have the pressure relay on the permeate line. Actually, this pressure relay we need to protect the permeate line from back pressure and to switch off the unit in case of back pressure. Then we have the concentrate line that actually consists of recycle and drain. So actually you could adjust the flow rate to drain and the flow rate for recycle. Depends on the protocol that you would get from us, or you could calculate by yourself. And this is the last pipe is the flushing pipe. So all the Ecosoft units are equipped with the flushing mode. As you may notice, it is installed in parallel to the drain flow rate, and every 6 hours during operation, this ball valve is opened, and then we remove all the solids from the membrane element. And of course, we have the power panel, and then we will look at it, I think, more in details later. So this is generally the answer to the question: what is the flow? What is the flow chart on?
Yeah, thank you, Rusty. But you just show us valves. So as I know, we used different types of valves: motorized ball valve and solenoid valve. So can you explain the difference between them?
Yeah, in all 8-inch units, we use only motorized ball valve, while in 4-inch commercial RO we use the solenoid valves. And we use the motorized ball valve for several reasons. First of all, to make a soft start. I will show it. On the screen. So this is the ball valve, and actually it comes from Danfoss, so it's a good quality motorized ball valve that opens during 30 seconds. And during 30 seconds, we have quite a soft start. And when we stop the system, the valve closes also for 30 seconds. So it means that we have a soft stop of the system without any water hammers. This is very important. So this is the first benefit of the motorized ball valve. And the second benefit that, as you may see on the camera, it has the diameter of the ball valve is equal to the diameter of the pipe. So it means that we would have much pressure loss in comparison to the solenoid valves. So this ball valves has many benefits when we talk about the water flow, pressure loss, and operation of the 8-inch RO units.
Okay, good.
Okay, thank you, Rusty. But let me jump to my first question regarding the permeate flushing kit and blending kit. You explain us how we can connect it, but could you please explain why we need it? In which cases we should use it?
Yeah, the blending kit, I will maybe I will show it on the picture. So now I will share the screen and I will explain. It is better to explain it on the scheme why we need that. Let's start with the permeate rinsing or permeate flushing kit. So during operation, I will also jump here. So during operation of this particular unit, Ecosoft MO3, it consumes from 4 to 6 cubes an hour flow rate. And during the forward flush, it would consume up to 10 cubic meters per hour. In some cases, not you, but in some cases, 10 cubes an hour is too high flow on site. So maybe you don't have enough water or pressure, or the diameter of the pumps are not enough to supply this amount of water. But to make the system operate in a regular way, we need to do the forward flush. So to do so, if you don't have this 10 cubes an hour flow, you may do it with the permeate. So what you have normally after all units, you have the tank, the permeate tank. So normally it equals to 1 hour capacity of the unit. So in this case, it would have a tank of 3,000 liters. And then you could use either the delivery pump if it's has enough capacity, or you could install a separate pump. You can use the flushing kit, and then you do the forward flushing with the permeate. So this is the first reason why we recommend to use the permeate flushing kit. There is also a second reason, is when your water has a quite a poor quality, and you would like to extend the lifetime of the membrane, or you would like to increase the intervals between the CIPs, the cleaning, the chemical cleaning. So then you also use the permeate flushing kit, because in the standby mode, the pressure vessels and the membrane are membrane elements sit in the permeate, and the permeate, having a low pH, could dissolve some amounts of salt, and then by this dissolving, actually the permeate flushing kit can extend the lifetime of the membrane. So this is the answer on the question on the why we need the permeate flushing kit.
Okay, good. So Rusty, by the way, what is the minimum pressure during the startup?
During the startup, the minimum pressure is around 2 bar. So this is the minimum pressure. So you should have it. This is the minimum pressure you should have. But the operating pressure of the not the operating, but the requirement for the inlet pressure is from 2 up to 4 bar. But I would like also to come back a little bit to the blending kit, because this is a second option that we have. And the blending kit, these are also the blending kit has also two reasons to use. Now you see it on the screen. So the first reason I have already explained. So this is when you need to adjust the permeate quality, for example, to brew the beer. But also there is another case where the blending kit can be used, is when you need a water of let's say 200 ppm salinity. This could be drinking water or water for plants watering. So when the requirements are not high, but your permeate is around 20 ppm, and then you could use the blending kit to increase the flow rate of RO unit. For example, you could install a blending kit on MO3, and then you could in some cases you could add 1 cube an hour flow, and then you could convert MO3 to 4 cubic meter an hour unit. And by this means, actually, you could optimize the sizes of the RO unit and to be more competitive in comparison to other players. So these are basically the answers to the questions.
Super. So we can save some money for our customers.
Yeah, you can optimize. This is sometimes it's very important to when the budget is tight and the customer would like to cut the cost. We have a question from Anton. Serial big system started from the 12 cubes, basically equipped with plastic high pressure lines. Is it safe? The plastic high pressure lines can stand the pressure up to 16 bar. So when you operate the unit within 16 bar pressure, then it is safe. But if you would like to go higher with the pressure, then it is not safe. Also, according to my experience, that when the temperature is high, for example, in the Middle East, when we sell units to the Middle East, we prefer to sell Inox version because at high temperature, the plastic pipes can stand less pressure. This is what we face. So also we should take into account not only the pressure, but also the temperature of the environment. I hope my answer, yeah.
Anton says thanks. Rusty, by the way, when you did the overview of system, we can see a blue valve near the pump. Could you explain what is the reason of this valve?
Yeah, I will come back. I will ask my colleague to show again. Maybe we can move the system. So this is the bypass valve, and it is always here in all units. We have the bypass valve, and we need this manual valve for two reasons. So the first reason is to do the startup, to do the soft start. So when you first doing the start of the unit, it have to be completely opened. What I'm doing right now. So basically, this is a needle valve, and when you do the start, when you load the system, you increase the pressure gradually until you reach operating parameters. And then when you do all the manipulation with the recycle flow control and drain flow control, you then finally close this bypass valve to fix the pressure. So this is the first reason. There is also the second reason. We need a bypass valve to move from the winter time to summertime operation mode. So during summertime, when the temperature is going up, the flow rate of the membrane elements are also going up. To keep the unit in the designed parameters, we need to decrease the pressure. And this bypass valve has to be opened during the summer period to decrease the pressure of the high pressure pump. So when we open the bypass, then we decrease the pressure of the whole unit, and then we come back to the designed permeate flow rate. So this is why we need this bypass valve on the high pressure pipe.
Okay, good. Let us also remind our guests, like if they have any questions, they are always welcome to text them and to ask us. So, Rosti, I have a question. So, could you please show us or explain how the membranes elements are installed, or what is the difference between these? Like for us to be clear and to be aware what the special difference is between.
So the installation of membrane elements. So first, before I would not give an answer. I would show an answer. But before showing an answer, I should mention that this is one of the most not complicated but tricky part of the whole story with the startup and installation. And I will ask another colleague of mine, Vitaly, to show how the membrane. How the membrane element should be loaded. So it would take some time. So we have we would require some tools. I believe you know everything but the bottle. So in the bottle we have the glycerin, and we have a special
it's
brush.
not a beer, no?
I don't know, fortunately or unfortunately, this is up to everyone, but this is not a beer. This is a glycerin, and this is a food grade. This is written in Ukrainian, but the glycerin comes from Czech Republic. But this is a food grade glycerin that we would require, and you would also require when you do the startup of the units. So first, you always, what you do, you unscrew the nuts on the high pressure line. So we will show it on one of the membrane elements. So we will show it on the last one, just for the convenience, but you would have to do with all three. So first you remove the clamp which connects the high pressure line with the concentrate adapter. I will be an assistant to this process. Yeah, then you have to remove the end cap. You need to use this basic tools. What you do, you remove the these half nuts from the. So this is the first step, how to remove the end cap. Also, I would answer questions that we have in our chat about the permeate. So during the first question is during the starting the unit, the conductivity is high. Can we return the poor permeate during start? So when you do the startup, the first 30 minutes, the first okay, I will stop answering and I will help. So this is we removed the nuts. So I will come back to answering later. So when we removed these half rounds, we have to screw in 3 bolts. This is, you would require to do this. Maybe you have a special tool, but if you don't, use a nut. That's the M10. So you just screw them in slightly, and then we will use them to remove the end cap.
Do we supply, Rusty, these parts with the system?
The bolts are not supplied, so this is what you have to source separately in the Brico market if you are in Belgium. And then so this is the way how we do it on site with the regular tools. So let's come back to questions. So I will now answer the question on the conductivity. So the first, if you can return the poor permeate during start, well, actually, we suggest that the first 40 minutes up to 1 hour, you just discharge the permeate to drain, because in the first portion of the permeate you have the components that preserve the membrane. So actually you have to wash them out, and I would not suggest to return the poor permeate during start, but may I ask you why you would like to return it? This is also a nice question, why you want to return it back. Then there is a question from Michael, which is the advice, what is the period, how we advise to do the maintenance of the showed installation? Well, basically, the question, actually, there are a few ways. The first way, so that you as a water professional company do everything by yourself. So in this case, we suggest to do the maintenance once a quarter. So maybe once in 3 months, you have to visit the site and to see how the system is performing. Another case, so you teach the local staff to do the basic maintenance, like look at the flow rates, check the pressure, put the anti-scalant. So in this case, maybe you will have to use once a year. You have to use the site to do the cleaning, to do the general inspection. So it depends on the way of maintenance you would select. So now we come back to Vitaly. So the first step, you remove the end cap. You remove the end cap, and it's important that you can remove the permeate adapter. And first thing, what you have to check, if this permeate adapter fit the membrane element that you are going to put in. So this is a film, a vacuum film, but in this particular case, it does not fit. Because this is a membrane adapter for with the size of 1.125 inch. And in this case, we have used a low flow membrane with 1 inch connection. So in this case, you have to find in the box a second type of connector.
You mean in a box which we supply?
It is in the box that is supplied. Yes, Alex. In this case, you don't have to go to Brico Market because it is supplied here, and I will show this. This is one that we have taken from the membrane pressure vessel, and this one is from the box. So you see, there is a difference in the diameter, and then you can size it, and you can see that this one fits. This one from the box fits the membrane element. So then I can put this back, and then I install a second one. So this is the end cap. Also, I would like to show what is inside. Mira, can you please show? So inside the pressure vessel, there is a plastic part that is somewhere in the end. We call it corona-like insert. So we will remove them. We will remove it just to show it to you.
Yeah.
So this is the corona like part. So never remove it from the pressure vessel. It should be installed. So it should be installed in the end of the membrane element. So we are going to load membrane element from this part, like it is shown on the arrow in the middle of membrane element. I would again draw your attention to this, and this corona insert should be in the very end. Vitaly, can you please explain what is it installed this way?
This way.
This way. So how you do it? So you can. And also, what is important to?
Yeah, so why do we need that corona?
Ala, just a moment. I will draw attention to another important thing. So when you do the loading of membrane element, always check that the O-ring. So please also take attention that the O-ring is only on from one side. So here you have O-ring, and on the end you don't. So the O-ring should be in the inlet of the water. So this is the right way how you insert the membrane element. Of course, you have to remove the film, and of course, you have to use gloves when you do it. And before you load the membrane element, you have to use the glycerin and a special brush. So what you do, you put a little bit of glycerin around the O-ring, and also you do the same. Here on the permeate inlet to let the adapter go in, so that you don't damage the O-rings of the adapter. So this is the story how you put the membrane elements in, and then you do the reverse way. So you put the end cap, and then you tighten all the screws. So this is now we can come back to them. So basically we spent maybe how many? Up to 10 minutes, a little bit less than 10 minutes to explain and to do the installation, the loading of the membrane element. So it's not so complicated, but there are some details that have to be taken into consideration.
First, we also have some questions in the chat. Please check it.
Yeah, let's. So could you explain? There is a question from Beston. I believe I spell your name, pronounce your name in the right way. So could you explain about the CAP process? So in general, so the CAP process is a topic for the complete Friday talk, and maybe this would be maybe the CAP process would be a separate story. But in general, there are few basic rules about the CAP. So first, you have to perform the CAP when the flow rate has decreased by 15% maximum. So it means that if your flow rate was 1,000 liters per hour and it went down up to 850 liters per hour, of course, the temperature is stable and all other parameters remained on the same level. So when the drop is 15%, then you have to stop the unit and do the CAP. The second reason when you have to do the CAP, when you have the 15% drop in the water quality. So if your permeate TDS was something around 20 ppm and then it jumped up to 23, 24 ppm, while all other parameters are the same. So this is also the reason why you have to stop and do the CAP. And there is also the third reason when you start the CAP is the pressure loss. I would like also to draw your attention to the unit. So we have the pressure gauges, and then you have the operating pressures, then you have the pressure after the first stage and the pressure after the second stage. So when the pressure drop has increased by 15% between these three pressure gauges after startup, it means that the membrane is fouled or scaled, and it has you have to stop the unit and you have to do the CAP. So it means when I say 15% change, it means that quite regularly you as a water professionals or dealers or a staff of the unit have to put the parameters somewhere in the list and then compare the values between each other, so that you know that this is 15% change in comparison to the initial values. So this is the CAP. This is when you have to start the CAP, and then the unit is ready for the CAP. So you can clean membrane elements on site. I would also like to show you. I would also like to show you that here we have the CAP inlet, we have the CAP outlet. So basically you could connect the SIP station here. So on the back part, we have the special valves that are in the operation mode. They are closed. So we have one valve here, second valve here. Of course, they have to be open during the CAP. And also, I would also show you on the permeate line, I would also like to show you that here we have. So here on the permeate line, we have also the ball valve that is closed. But when you do the CAP, you have to also connect the permeate line to drain or to the CAP station, because you would have some permeate production during the CAP. And then you can also take this, you can use this valve to connect it to the CAP station tank. So this is basically how the unit is prepared for the CAP process just on site. And then you have the CAP procedure that consists of normally of 3 stages. So you have the alkaline cleaning, and then you have the cleaning with the biocide, and then you have the cleaning with acid. And of course, between these 3 stages and after the last one, you do the flushing with the permeate. So this is the general answer to your question about the CAP process.
Okay.
Some
more questions.
So there are some. So this was the question when the. So I have already answered the question from Weston about when the CAP needs to be done, the 15% change. And then I have answered what chemical should be used. Normally we use the chemicals. We may come back. Actually, we suggest about the chemicals. Also, there are a few concepts, actually 2 concepts how to do it. You can use special chemicals, like special cleaning chemicals, which we also supply, that are made by BWT or they're made by Ecosoft. And also you may use the traditional chemicals like sodium hydroxide or chloric acid. So these are 2 possible ways. It depends on you. I always suggest to use the special chemicals because it's much safer to be within pH limits, not to chemically damage membrane element. And the question is, when do you require to change the membrane? I would suggest that if you do the CAP and your recovery of permeate flow rate or recovery of rejection rate, so if you are not satisfied with flow rate or you're not satisfied with the TDS level, so in this case you have to change the membrane. So if you did the CAP, no result, the customer is not satisfied, then it means that you have to change them. From the time point of view, you can do up to 8, according to our experience, you can do up to 8 chemical cleaning when you use the DuPont or other high quality membrane elements, and you could do up to 4 CAP cleaning when you use low cost membrane elements. So this is the answer. This is various answers on question when. When do you require to change the membrane? There is a question also from Jalal. Could you please explain why the membranes are installed in series? In diagram for MO6 unit, you have 2 modules in parallel. What is the required cross-flow velocity? So when we design RO units, we consider several factors. So first, we consider the typical water quality that we deal with. Normally, we deal with these particular units are designed for the water TDS of up to 4,500 ppm. Also, we take into consideration the size of the pump. So, for example, in this case, all the membrane elements are connected one after another, or we can also call it in series. So it allows us to use less powerful high pressure pump and optimize the cost of the complete unit. And also we meet the parameters of we meet the requirements of the cross flow velocity. When we design the units, we do the calculation to be within 8 to 10 cubic meters an hour flow rate per pressure vessel. So 8 to 10 cubes an hour. So this is how we size the pump. Of course, when we have the water test and when the plant has bigger sizes, so in this case we could design in various ways. So we could put some pressure vessels in parallel, but this is again the question of the custom design for the particular site. There is a question.
Yeah, nice question about membranes.
What kind of membranes do you need as per RO? Could you explain about seawater membrane and brackish water membrane? At what conditions do you need to have seawater or brackish water? Also, I would add a little bit to this question, and because in some cases we would require tap water membrane elements, because in the majority of the cases we deal not with the brackish water and not with the seawater, but we deal with the tap water RO units. And to answer this question, I will jump to our web page, and I would like to show the membrane portfolio and explain it, answer this question. So here on the page, you may see 6 membrane elements, and they are different. I would not, at this moment, I wouldn't go in very detail, but I will give you a general guidance. I will share our experience, how we size the membrane, how we select the membrane element. So I will start with ELP 4040. So this is I would say this is the medium flow, high rejection membrane element with low cost. And I would use this membrane for those sites and for those projects that has limitations on the budget and that have limitation on the cost. So when the customer is asking you to decrease the cost of the complete installation, so this is a good membrane element to meet this requirement. But remember that the lifetime, according to our experience, the lifetime of this membrane element is around 2 years, and you could do up to 4 CIP processes with this membrane element. Then we have the FilmTech XLE 440. So this is the most popular membrane elements in our product portfolio, and we use it in the most applications for 2 reasons. The first reason is the high flow, but low rejection membrane element. And when we deal with the tap water, and sometimes even when we deal with the brackish water, and we would like to produce water for plants watering, for household application, not household, but for the drinking water application, when the requirements on the TDS are not very high. But the FilmTech XLE 440 produce the most amount of water with the lowest possible pressure. So you would also save a lot of energy to your customer. Then we have EcoPro 440. So this is the most advanced membrane element available on the market globally. And we use this membrane element when you need to have a high flow RO unit with the high requirements on the TDS of the permeate, especially when you have the requirements for the silica or for boron. So when you prepare water for the agriculture, for example, for the watering of greenhouses, for tomatoes, for cucumbers, for flowers, so the very important are the concentration of bore, and this is the element that can reduce it quite effectively. But then we have a BW30 Pro 400. So this is a very traditional membrane element that is mostly used for the brackish water, but it is used in those cases when it was already in the projects for many years, and you do just the replacement. So you supply the membrane to the existing plant, because I would say this is low flow and high rejection membrane element. So you would require quite a high pressure to produce enough water. And then we have BW30 HRLE membrane element. So this is the membrane element that provides you very good rejection, very good, very efficient water treatment, and will provide you quite a high flow of water. So I would put this element in the middle between XLE 440 and EcoPro. So it is not as expensive as EcoPro, but it provides you quite an effective removal of salts. And also the last one is XFRLE. XFRLE means extra fouling resistant membrane element. So these are the membrane elements that used to treat surface water, or it is used, for example, we have one of the projects to treat water collected from the roofs of the big factory to supply it to the steam water boiler. So when you have a lot of organics in the water, and then when you have a lot of turbidity, when the turbidity is high, so this is the membrane element that would resist fouling, and this is quite effective in CAP. So when you do the CAP of these elements, they can be cleaned effectively. So this is quite a long answer to the question about membrane elements. So I would finish with the brackish water and seawater. So basically, we say the brackish water is the water with the TDS starting from 5,000 ppm and up to, I would say, 20,000 ppm. So this is the brackish water, and everything which is 20,000 ppm and above is already the seawater. And when you have this kind of water, you select tap water, brackish water, or seawater membrane elements. We supply units mainly for tap water and in some part of the brackish water treatment. There is also a question in the ship building market. It is not possible to drain into the sea. A good question. A good question about the, I think I have to read the question because not everyone see the question. So in the shipbuilding market, it is not possible to drain into the sea the results of the membrane cleaning. It is true that it exists green products that could solve this problem. Well, we do not have such an experience, but maybe some of our guests has. I don't know, maybe other people could share this, could answer this question. If not, we will research a little bit, and we will come back to you after I will come back to you next week with some ideas on how to do that. And there is one more question. For example, I'm using the borehole water. Can I use BW or seawater, or do I have to use other type? So the direct answer to your question, let's look at the TDS. So what is the TDS of the borehole water? Because normally the borehole water has the TDS either as tap water, sometimes as brackish water. It depends on the area, and it depends how far or how close you are to the sea or to the ocean. Less likely you would have to use the seawater membrane element.
So we already 1 hour online. So what we should do? We can continue, or we?
I would suggest our guests to ask questions and to keep on answering if there are more questions. If not, then we would stop at this point, not to break the schedule. Yeah, but anyway, this was a very good discussion, and yeah, there is one more question from Jalal. In case you have a very good pretreatment with ultrafiltration, do you still need the cartridge filters? The answer would be definitely yes, because the cartridge filters are not the cartridge filters that are here. They are not designed. Actually not designed, they are not installed to reduce the turbidity. So they're like polishing and last stage sediment filtration, just in case you have some sediments or rust or some other leakages from the pipe. So in my opinion, and in our recommendation, you have to use the sediment filters, even though you have the ultrafiltration as a pre-filtration. So in this case, you would have to replace them quite seldom. So maybe once in 6 months, but never remove these cartridges from the housings, because they are there just to protect the membrane elements just in case.
You're welcome.
So at this point, I would like to say thank you to Alla and thank you to Alexei that you joined our Friday talks.
Thank you,
Thank you, Rusty.
Yeah, thank you to Jalal, to Beston, to Mikhail, and not to forget everyone, to Uwe, and of course to Anton for nice questions. And so see you on our next Friday talks. I believe we would do it in 2 weeks because we also need some time for summer vacations. What I also wish to everyone, if there are people who hasn't taken summer vacation, it's time to do so. Okay. And of course, I wish everyone good Friday and good holidays.
Yes, thank you, Rusty. Thank you.
Yes, thank you.
Yeah, bye, and stay with us. And on Monday, you would have this video online downloaded, and you may watch it again, and you may also share it with your colleagues. So bye, and stay safe.
Yeah,
Bye.
bye everyone.